This is the directions for chapters 8 through 12, trade-specific assignment. Each of you were asked at the beginning of the class which trade you were receiving your certificate or degree in. This assignment is designed specifically for that trade. You will be required to complete 15 questions on this assignment. I would encourage you to begin at least 1 month before the class is to end. This is a test grade that can't be excused. You must turn in this assignment to pass this class. Tests are worth 50% of your grade in this class. You can find a guided notes handout under the course content section in Blackboard. There is a video with each section. You should only do the section that is for your trade. This video gives guided examples of each of the problems for you. Under each guided problem, there is a place for you to do the work, the actual problems that are on your test. You should watch the video with the guided examples and take notes before you attempt the test. If you should happen to get the exact same problem with the same numbers as the guided example, pick a different problem. Pick a similar question. You will have unlimited times to get the problems correct. You must turn in notes from your test, or 20% will be deducted from your test grade. You can turn in the notes that I have provided, or you may make your own notes with the problems numbered. You may turn these in by scanning them to my email or dropping them by my office. In order for your grade to not receive the deduction, you must turn them in within 24 hours of completing the test. Okay, so our very first example goes over the protractor. Okay, and so you really don't have to have an exact protractor to do these problems, but we're going to kind of make an estimate, I guess, of these angles. So the first thing that we know is if we want to make an example of a protractor, I'm going to draw all of my angles going the same way. I've drawn an example of a protractor up here at the top, and so basically angles that are going to be between 0 and 45 would fall in this section. Then we would have our 90-degree angle. That would be a right angle. Then I've added another 45, which is going to get you 135 degrees, and then we've got 180 degrees over here. So again, we're going to kind of make a rough estimate of what this is. So I know that if I want to draw an angle that is 27 degrees, okay, that it would fall somewhere in between 0 and 45, probably a little bit closer to 45. So our angle should look like, right, something similar to this. So that would be about 27 degrees, an angle that falls in between 0 and 45. We're going to cut about right in here. Okay, 100 degrees. Well, 100 degrees would be an angle that is bigger than 90. So when I draw that, I would start at 0 and go a little bit past this 90 to about 100. Okay, now, if we actually if I was actually making you use the protractor, we would be a little bit more exact. 153 degrees, well, we would start at our 0. And we know that 153 would be in between 135 and 180. So we want to kind of cut it right in the middle right here. So our angle that is 153 is going to kind of look like this. 138 is going to be barely over 135. So we would start at our 0 and go a little bit past 135 to 138. Okay, this 153 probably should have been a little bit wider, right? Because it almost looks like I'm at 135. Probably need to make that one just a little bit bigger. And again, I'm not drawing these perfect. We're just kind of making estimates because these problems are going to be choices that you're going to be able to pick. And so I want to make that 153 a little bit wider. 67, well, we know 67 is between 45 and 90, so we want to do right in here somewhere. Okay, that would be my 45-degree angle. And 47 is going to be tiny bit over 45. So we would start at 0 and go a little bit over 45 to get us a 47. Okay. So something in here. And this, if you look at these two, they would look like they're almost the same. 67 needs to be a little bit wider than the 47, but these are just rough estimates of this protractor and how you would use it. Okay, in the pipe flange shown to the right, the 8 block holes are equally spaced. What is the spacing of the holes in degrees? Well, here's what we know. We know that a circle has 360 degrees. And if we are spacing something equally, we would want to divide by 8 to get the number of degrees since they are equally spaced and they're 8 apart. So 360 divided by 8. It's going to give me 45 degrees. Okay. Find the missing dimension of the regular hexagon shown to the right, round to the nearest tenth. And so we're looking for this diagonal distance right here. It would almost be like it's the diameter if it was a circle, but that's the piece that we're missing. And we actually have a formula that says that this S is equal to R, and R is halfway in between this. So this would be R, and this would be R. So, and this is our side length, which is 20. So we really just need 2 of these. So we would just do, since S is 20, we just need to do 2 times our 20 and get 40 centimeters for the length of this missing part. Find the area of the given figure to the right, round to the nearest whole number. So we've got the first little section right here is a rectangle. So let's just talk about this little area right in here of this shape. That's our rectangle. Well, to find the area of a rectangle, you just want to do length times width. Okay, so we would do 4 inches times 7 inches, which is going to get us 28 inches squared. Okay, now we've got this trapezoid down here, and we need to find the area of it. So that's going to be a little bit different. How do you find the area of a trapezoid? Okay, so the formula for the area of the trapezoid is here, and the A and the B are going to be these parts right here. This is your A and this is your B. So when I start plugging this stuff in, I would have 4 plus 12 divided by 2, and then the height of the trapezoid is going to be this section right here. Well, I know the whole thing is 11.5 inches, so if I subtract the 7 inches, that should give me the difference. So to find the height, I want to take 11.5 minus 7, and that's going to get me 4.5. And I'm going to say 4.5 just to make this a little bit easier to type in the calculator. Okay, so 4 plus 12 gets me 16 divided by 2 times 4.5. Okay, and that's going to be, sorry, I meant to put 4.5. $36 and we're talking about area, so 36 inches squared. So there's my area of my trapezoid and my area of my rectangle, and I want to add those. 28 inches squared plus 36 inches squared. That would get me my answer of 64 inches squared. Okay. So that's going to be our area of that figure.